Welcome. In this video, we're going to introduce the concept of an infinite series. So let's begin with a calculator warm-up. Using a calculator, work out the sum below. Please pause the video now and work out this sum. You should have worked out that this entire expression summed up is 3.14159. Does that look familiar at all? Well, 3.14159 is approximately pi. In fact, this number is pi to about 5 decimal places. So this is pi to 5 decimal places. And we can actually do this a lot further. That is, we can continue this series here to get a more accurate representation of pi. So that's 3 plus 1 over 10 plus 4 over 10 squared plus 1 over 10 cubed plus 5 over 10 to the 4th plus 9 over 10 to the 6th plus, 10 to the 5th plus 2 over 10 to the 6th plus 6 over 10 to the 7th plus 5 over 10 to the 8th. And I'll stop here because I could just keep going. And now we have pi accurate to many more decimal places. Well, what we have just done in this warm-up is we've figured out the sum of the first 5 terms of a series. And we've represented the number pi as an infinite series. Now let's actually define what a series is. Definition: a series is a sum of terms of an infinite sequence, and this is denoted as the sum of a sub k, and we can include limits sometimes, or we can just write this as a sum of a sub k. And that is what we did here. This is the sum added up. This is our whole series, and if we add it up, it will eventually get to pi. Now the sequence of partial sums, and that's what we have here. We worked out the first partial sums to this series to get these 5 decimal places. So the sequence of partial sums has the following terms, and bear with me, I'm going to move the screen so I can write out a few of them. S1 equals A1. So our first term of partial sums is just the first term, A1. S2 equals A1 plus A2. S3 equals A1 plus A2 plus A3. What do you think S4 equals? If you said A1 plus A2 plus A3 plus A4, you are correct. And we can keep going in this manner until we get to the nth term. If the sequence of partial sums has a limit L, then that infinite series converges to that limit. So if we can actually write this out to some limit, say this equals some number. When we add these all up, this equals L. So let's suppose that. Then we can write this summation as the limit as n approaches infinity of the sum from k equals 1 to n of a sub k, and this is just the same as the limit as n approaches infinity of the sequence of partial sums, which is equal to L. And now this is the case where the sequence of partial sums has a limit L, so the infinite series converges. If this is not the case, then the infinite series will diverge. So if the sequence of partial sums diverges, then the infinite series also diverges.